Hey,
Hey,
how you doing, man?
yeah, I'm doing great. How you guys doing?
I'm doing good. I'm doing good. It's where are you from? Where are
I'm
you?
I'm from Kuala Lumpur, Malaysia.
Oh, nice. What's the time in Malaysia right now?
It is around 3 a.m.
Mm,
Yeah, it's nighttime.
okay, nighttime. I
Yeah,
mean, morning time, 3 a.m.
yeah,
Okay,
yeah,
okay.
yeah,
Yeah. Okay, so you have a great view behind you, and
yeah. It's because it's like this place is sort of like in the center of Kuala Lumpur. I have like Petronas Tower, like 400-500 meters from my place, and like I can see all. It's in between all the buildings.
really nice. No, it looks awesome. And you have a great setup. You can hear you great, and it's not a coincidence because you've been doing you have your own YouTube channel for the last kind of year or so, right?
Yeah, I started YouTube like around 1 year ago, and it is like sort of like you can say a coincidence because it's like a very funny story because there was this one guy who was always messaging me on LinkedIn and
Okay.
asking me about like different concepts and different stuff, and then I was like giving sort of mentoring to a lot of different people, like at that time also like 20-30 people. Just it's like free, like I'm not taking any money, just like helping others out. So that person used to say that you have like such a good voice, and when you explain something you are like really into it. Why you don't create videos and stuff? So I
Okay.
was like, yeah, it's like too much of a hassle. And then I created 1 or 2 videos and I leave it there like 3 years ago, 3-4 years
Okay.
ago.
Okay.
And then like I created like 4 videos, and then after like 1 year ago I checked my YouTube channel. One of the video has like around 30,000 views, the other one had like 10-15,000. I was like, oh, because this is something that I was not, I thought like those videos maybe they are still on YouTube or no. Then I was like, and then that same person was asking me that why you're not creating videos. And
Oh, I
all of
see.
the sudden I just get a push to, I was like, okay, I will create like 3-4 videos, and that's it. I created the videos, I get the good response, I was like, okay, let's do it.
Nice. What was the videos? What was the what topics do you actually cover?
Yeah, so in the start I created the video about MongoDB like around 3.5 years ago, because at
Nice.
that time there was not much content on MongoDB. Right now you can see a lot. So
Right.
I created video about how you can create views, how you can do joins and different sort of things, backup and
Yeah.
XYZ. And then like now it's like I create videos on all sort of topic like related to system design. It can be related to databases, related to AWS services, related to caching, scaling, like that.
Nice. So you have how kind of alive is your channel? Do you do this every month, every 2 weeks, every?
So previously it was like I was posting video like almost like one video every 2 week, like it's
Okay.
like that. But then like for past 2 months I just updated like the frequency, and now I'm posting a lot more because and now I have like 2-3 guys who are helping me creating the
Oh, nice.
content and all that stuff. So now what they do is like from all the podcasts they create like small clips and they also post that. So now it is like I think from Monday to Thursday, there is a video uploaded every day, like
Oh,
one
nice.
video on Monday, Tuesday, Wednesday, Thursday, then like the next week. So
And
yeah.
and what's your favorite topics right now? I mean, if it's not MongoDB.
Uh, right now, I would say like the infrastructure, system scaling, monitoring, these are something that are like right now I'm also interested in, and I'm learning and creating videos on.
Got it. Are you a Kubernetes fan? Are you a serverless fan? You're agnostic to it?
Yeah, this is something that I believe that it is based on the team size and the
Okay.
project, because
Okay.
it has happened that some guys they just love, for instance, they just love a particular thing, right? They say, oh, cloud formation is very easy, it's very good, like because they know, right? So they try to fix that thing in every project, in
Right.
every team. It
Right.
can be a case that you have like a very small team, and
Right.
then you might go with like elastic beanstalk, right? Like it's not like you should always have like ECS cluster, ECR, or EKS, that setup. So I am that kind of a person.
Got it. I'm seeing more and more kind of asynchronous flows that kind of not, we don't have, if you don't have a client that actually goes into API gateway and then needs to hit someone, and then you need to return, the sync flows and return the response. I'm seeing most of those flows go into Kubernetes or in a container-based system. It doesn't have to be Kubernetes. And then I'm seeing more kind of reacting to events, kind of event-driven flows going to serverless. It's interesting to see this. It makes sense. It also, serverless is hard. I mean, there's the cold start problem and the latency problem, and the other side of it is if you do kind of reserve concurrency, now you have a cost problem. So I'm seeing this dichotomy. But what you're saying basically, first of all, some people will just choose if they have everything looks like if you have a nail, everything looks like a hammer for them. So some people will just use the same technology over and over again. And you're saying it really depends on the job to be done and also the team structure. Yeah, makes a lot of sense. It makes a lot of sense. Yeah. I mean, if you need an EKS cluster, you also need someone to manage it, right? I mean, it's not something
I have seen that like a lot of the times that some guy like actually built like a very complex infrastructure, and it is like a startup, and they have like 3-4 guys total, like all 3-4 guys, the whole development team, and then that guy left the team, and then everybody is like thinking that how we will actually manage it, because they have no clue about Terraform, they have no clue about like the whole API gateway, ECS, and then it's a mess. So I believe like just based on your team capacity, then decide the architecture.
Right. It's interesting. It's at one point at my previous company, we used to we had a data pipeline that was it had handled a lot of events, like a really, really large chunk of events live on and we used Kafka Stream for that on Kubernetes. And we were a small team, like 13 people total, and we used this on Kubernetes. And then we had problem with the fact that it's the JVM was running on Kubernetes. That was 2016. There was really a lot of problem with JVM on Kubernetes. And we had RocksDB running on this, and the machine kept. I mean, at one point after 3 years that from time to time, we had to go into the machine, clean it up, move the cursor back of the Kafka. I just told one of the developers, listen, man, I think we chose the wrong tool. We don't have a dedicated person that knows this shit, that knows how to handle. Maybe we did a mistake 3 years ago. Maybe we should choose a different tool. Talk to the product guy, see if we can kind of alleviate some of the kind of we had to do some the duplication stuff. Maybe we don't really care about that and just select something simple. I think it's really, really important, because we thought we were growing, and then we're going to hire more DevOps, and it's not always the case. It's sometimes you don't grow. Sometimes so I totally can relate to what you're saying.
Yeah, because on all the cloud providers right now, so they have like, I think it's also very good of them that they have like different category of services. One is like fully managed services. The other one is like, which is like partially managed, like you don't have to do the heavy lifting. It's like already configured, but you can so then the one is like you just do everything yourself, right? So I believe like just now they have like a lot of managed solutions, so we just go with that. Like it's no point like setting up everything. Like for instance, like very easy example so that all of the people can understand that, for instance, you have to deploy a WordPress website. You can set up an EC2 instance, and then you can install MySQL, then you can install like the Bitnami or whatever the server is, and then you set up everything yourself and run that particular application. The other process is in the EC2, you have like the images. You can there are options. AMIs. There's an option. They say, okay, from Bitnami, it will set up the whole WordPress from one click. Boom, it's done. Right. The other option, the second option, like if you want to do some sort of POC, and it's not like you just want to set it up for like few days, you go to Lightsail. Lightsail is a VPC. The cost is like, it will not go beyond. So you say, okay, $5 a month, you set up the WordPress website in 2 minutes, you do the POC, extract the backup, done. So
Right.
it's based on the scenario as well.
Right, and it's true for everything, right? It's true for your
Yeah.
CI/CD process, whether you're going to run a Jenkins or whether
Yeah.
you're going to use GitHub Actions or Circle CI. It's
Yeah.
true for any infrastructure. Sometimes you have to go with
Yeah.
with a managed solution. I always appreciate the people who say our default is managed solution. We're starting with a managed solution.
Yeah.
Because I mean, I mean, you're basically loading your problems to someone else. I mean, and in most cases, it's not your business domain. It's not how you make money. It's just it's not where you want to be differentiated. Actually, you want to make room for putting your best people on where you want to be differentiated.
Yeah, that's true.
Yeah. So you're in our community, and you posted, I think, a couple of weeks ago that you've just issued a new book called Designing Scalable Systems. Can you tell us a little bit about this? Why you posted this book, and what's it all about?
Yeah, so this book, Designing Scalable System, like I was thinking about it, like you can say around like 1.5 years ago about writing the book. I have the title in my mind and some of the chapters and the layout, but I was not sure, like obviously what it will turn out to be. Initially, I thought like, because there's this problem that right now I'm doing like mentoring for like a lot of people, and most of the people that I do mentoring, some of them are like, we don't know the pathway, like what is the next step, like what is the next thing I should learn in this software engineering realm. And then some of the people are like, we don't know, like, we have built the solution based on the tutorials, based on the guidelines,
Right.
but we are not sure that when we will deploy that to production, then and a lot of users will use that platform, it will actually work or no. So there was this concern. Then I was thinking that okay, this concern is actually not for like these 20-30 people that I am actually talking to. This is something that everybody in the market is thinking, because of all the medium and junior or senior level, all of these guys are thinking about it. So I was like, okay, I can create a book, or like I can just create a course. So in that I will cover almost all the aspect of the whole system design. And then because someone read that particular book, then they know, okay, these are the main like concept. Obviously there can be other concepts, and then they get the whole gist of it. They understand, okay, if we follow all these things and we go more deep into that, then we are like very certain that our system is very scalable and can handle like a lot of load.
Right. So it's quite. So that's the first thing that I went through the book. It's quite extensive. It talks about the APIs and software architecture, system design, databases, infrastructure scaling, monitoring. You're going through big data and analytics. You're going through security, I think, and of course cost. So you're going through the entire process. How long does it take to write this kind of book? I mean, it's
so it was like, I can say like from 1.5 years, like I was actually working on that, but it was not like I was working like giving the time every day. But for past like 8 or 9 months, I was actually giving like 1 hour, 2 hour, or sometimes like more, like 4 or 5 hours every day, and just writing some more stuff. And I was like, and then in the start, like it was very small. I had a plan that it will be a very small book, and maximum it will have like 100 pages, and now it is like around 270 something pages. So because but I have this thing in mind that I will cover all these aspects, because all the people, like I hear when the people pain point, like it's not like everybody pain point is like choosing the right database. Sometimes the people say that, okay, our system is very good, we are have this millions of users, but our problem is that the cost is very high. And then for them the solution might be that use serverless, use lambdas to reduce the cost, right? So for them they need that particular chapter. But for some other guys, their problem might be that we have like a lot of data, and or maybe I haven't worked with IoT system, and now I am exposed to that particular project, and there's like a lot of data, how do I manage it? And then they need to understand like, okay, different sort of like databases like DynamoDB, Elasticsearch, how to manage this big chunk of data archival, how we can move the data to like S3 Glacier. That is like sort of in that way. So then in that way I was thinking that okay, I need to cover like all these aspects. So I will, it's not important that I write like a very detail in every chapter, but like I will write the chapter, I will give the concept, like in big data, like how, what's the goal. Like first we need to decide, like before creating any big data pipeline, that what is the goal, what is the value that we need to achieve from that particular data. Okay, we decide, okay, from that data we want like what's the future prediction of orders. So based on that we can tell our manufacturer. So in that way then we extract the data, fetch the data, clean it, and then we create the whole pipeline. So I talk about these things as well. It's not just the tech book, like you just go there. I'm talking about Kinesis fire hose, I'm talking about like this I just talk about the business aspect as well, the people know why we do this. And the very main thing is that before the start of every chapter, in the introduction I talk about the why I have written this particular chapter. So it's not like I just put it there. So there's a reason why I have done that. So I have added that in the start of every chapter.
Got it. Nice. And when I started kind of going through the book, I saw, I was surprised to see soap. People actually using soap. I mean, is this still a thing? I don't know. Is it? I mean, I haven't seen it since the you using soap with XML. Is this what's going on now? People are still using it.
I believe like in the API protocol, like when I was around exactly like 1 year or 2 months ago, I was working on a banking project. So it was like a very large scale banking project of KFHK, Kuwait Finance House. And then we deployed that particular banking project in 3 different countries. So in that banking project, the whole project was like the new one. We revamped it to Angular, Nest.js, and like it was all nice. But the core banking APIs, we cannot update it because this is something that bank does not like us to touch. That was using SOAP. And at that time, because I knew that SOAP, like some old system used SOAP, right?
Was it a Java-based system or?
Yeah, Java-based system. So I knew that, old system used SOAP, but then I knew that mostly like in fintech sector, healthcare sector, if you're working in that sector, don't be surprised if you just, the people show you this payload, and because it's a very ugly payload, just to be honest, it has like a lot of unnecessary information as well. But it has like, on the positive side, it has like a lot of good things as well. It has like retry mechanism. It's in terms of security, it is very good. So you will see that. So the point is that, okay, we have SOAP, and in the chapter I have explained that what is SOAP and where it is used, what are the real world applications. And similarly, like if you talk about like other, like JSON is like very common, everybody is like using it. So REST, so then like for every protocol, what's the use case and real case studies, like in that protocol you use that in this particular case study.
So I think that's what I like about it. It's I mean, as developers, I mean, I'm not working in legacy systems for a long time. We tend to forget how much of legacy is important in our world, legacy system, how much of the infrastructure is built on legacy. And I have to say that I kind of like it, because there's also a nice segue from SOAP to REST and GraphQL, which is very different from REST. And you have to figure, it's a nice segue, and ending up with webhooks, which was a surprise to me. I mean, is it an API protocol?
Yeah.
I mean, so it's it makes sense. It makes sense to put this in place. So what was your favorite chapter to write? Do you have a favorite chapter in this book?
So my favorite chapter is scalability, because the book name is also like, Designing Scalable System. But obviously we cannot talk about just about scalability, because making a system scalable, it's very important that we choose the right database, right? Okay. So there's a separate chapter for database. There's a separate chapter for the API protocol, because sometimes the system is slow, and the main reason is that they haven't choose the right protocol. If there's a one-way communication between two services, then you can use like SQS in AWS, queue, right? You
Right.
just put the data in the queue, because it's
Right.
a one-way communication. You
Right.
don't want like the return back. So
Right.
then the other service will get the data from the queue and process it and do it, rather than just doing a normal REST API call. So
Right.
this is one thing. Then if we talk about like then there are like multiple factors. Like in database, you want to do searching, right? And then you have like millions of record. So if you put that data in like MySQL or like RDS, you say, oh, and then I can search, it's not good. Some guys say, okay, I will put it in a NoSQL database like MongoDB, and then I will search, it's good. Still no good. MongoDB say it's very good, but yeah,
Yeah.
not good.
Yeah.
But if you put that in Elasticsearch and then do searching, then it kind of make more sense. So you have to understand that based on different like aspect, you have to choose the right tool for that. Yeah, that is like something that is very important to make your system scalable.
Right.
Then the very like most important part is like the caching strategies, because you can cache your query results. You can cache your, obviously everybody is doing the web page and all the assets and all of these things. This is something that you can cache. Then in that way, there are like a lot of things that you can actually cache to make your system fast. Like if you talk about like the architecture of Instagram and Facebook, I have like looked into these architectures a lot. So they talk about that they have like separate dedicated databases and caches for every different regions. So if I request something from Facebook, so it will check from the Kuala Lumpur, nearest to Kuala Lumpur is the Singapore, right? So it will go to Singapore, come back. But if I'm requesting something which is not in the Singapore region, it is in the Africa something region, then it will fetch the data from that database, and then it will also store in the Singapore region as well. Because the next time when I query it, it will not go all the way to Africa server. It will fetch it from here. So these are different strategies like cache aside, inline cache, write back cache. So different things that I talk about, like how you can apply these different strategies to make your system fast.
Okay. You're talking about scalability. A lot of time people talk about scalability in the aspect that you're talking about. How many requests? What's the volume of requests? The scalability also, how many developers can I onboard to my team? It's a different part of scalability. Also a huge problem. I mean, is this architecture scalable for larger teams? That's also, and most of the times building the architecture that is scalable for larger team from the get-go doesn't make sense, because it's so scalability is a loaded term for me. But I agree that databases, understanding the access pattern for databases, that's the beginning of understanding what kind of, I mean, it might be that RDS is good for you, it might be the MongoDB with the right sharding key is great for you, but if you need to do join between different sharding keys, then not join, but kind of running stuff. There's no join in MongoDB, but that's awesome. So and then you go through monitoring, right?
Yeah. So monitoring is also like very interesting topic, because right now, like most of the companies are now starting to invest in monitoring. This ELK suite, like it's expensive, but still, like people are paying for that, like thousands of dollars. So because the reason is that now through monitoring they can understand that maybe the website is working fine for them, right? In my region I can see, oh, the loading time is 1 second, but for someone in India or Pakistan or someone from Canada, like far away from Malaysia, they are facing like a 15-second load time. How I get to know about it, right? It is through the monitoring solution. Then another important aspect is the distributed tracing, because right now most of the systems are moved towards like microservices or layered architecture, like and then you have like a lot of separate projects, and sometimes they are in separate like technology as well. One is Node, Python, and then when you face the error, you start debugging from the first service, right? And then
Right.
you think like, okay, the issue is in that particular service, that it is not working. But without like obviously the distributed monitoring, you
Right.
have to track the request, and then it might take you days. But
Right.
with distributed tracing, you can see, okay, this request first hit this particular lambda, this lambda
Right.
calls this particular ECS, this call this, and then you see, oh, there it is like actually broken. Because
Right.
there's a concept of like, whole trace. So
Right.
you have this like ID, transaction ID, and
Right.
that transaction ID is like sent through the whole life cycle. So that is something very important that I wanted people to know.
Right.
So I talk about like these concepts and like why it is important, like network monitoring and these different sort of things.
Yeah. Totally. I think that kind of, if you're familiar with open telemetry and
Yeah.
I mean, just reading through the doc site, understanding the terms, what is a trace, what is a span, and
Yeah.
understanding the mechanism. It's a very simple mechanism. They just want
Yeah.
all the system to talk in the same. I mean, just you put a trace ID. I'm going to pick it up. I'm going to use this trace ID. If not, I'm going to
Yeah.
create a trace ID. And then in the end, you go into a New Relic, Datadog, I don't know what,
Yeah.
your own solution, and then you can just go, this is the event. Just let me
Yeah.
look just on this request and just follow it.
Yeah.
That's it. I mean, when I'm talking to a lot of teams, I'm still finding that the expense on monitoring is crazy. I
Yeah.
mean, it almost goes into 10% of cloud spend when I
Yeah.
talk about expensive monitoring. So it's interesting. There's some nice companies in the field right now that are trying to solve this problem of basically kind of filtering events, not sending all the events, and it's a very since Splunk, it's a very hot field.
Yeah.
This field.
Because this field is sort of new, because it's not like people know about monitoring for like ages. So
Right.
now it is something that all the companies are using, and
Right.
the concept is same. Like if you talk about Datadog, ELK suite, like all these new relic, the
Right.
concept is same. The span, the
Right.
transaction is
Right.
same. So now obviously they are thinking about like adding some machine learning on that, anomaly
Right.
detection, these sort of things.
Classic. And it's what we call in entrepreneurship. It's a red ocean. Everybody. I mean, it's a battlefield for customers. There's a lot of money there. There's a lot of value. There's compliance issues. You need to save stuff. There's other side of compliance issue. You don't want to save the GDPR information, the emails.
Yeah.
No, it's a crazy area. It's a crazy area. And then you finish with you go through security, and then you finish with cost optimization. I mean,
Yeah.
system designing scalable system has to end up with basically
Cost.
Yeah.
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 This is something like that's very interesting, because right now in my current job as well, like most of the time when we're designing anything now, we obviously have this concept that we will tag this particular resource. So after 1 month, we know that this particular change that involves provisioning X amount
Right.
of resources, how much does that cost? And before like deploying that, we have this cost analysis using cost calculator, and then we check that how much accurate it is, right? And then based on that, then we see, okay, how we can optimize it, how we can optimize the cost. Or like we are writing data to S3, like every other request, we can use like Kinesis Firehose, like stream it, batch it, and instead of writing everything, like we batch it, put 1
Oh,
GB
nice.
as a whole, right?
Nice.
It reduced the cost a lot. Like if you talk about IoT system, the other day I was doing consultation with one of my client in Norway, and we are doing calculation for their IoT project, and we just did batching for the data, and the cost was reduced like 10 times. We just
Yeah.
did batching for like, I think 1 minute, just time span, and the cost was like, it was like crazy how much cost we can save through it. And we just have to add like 1 or 2 servers, like it's very easy. So but in some cases you cannot do it. I just also explained them, in case of you need like some real sort of like charts, in that don't add this batching, then it will kill the purpose. But in that case, you feel like, okay, I can do batching, is like 4 5 minute 10 minutes delay in the data is not costing me, then do batching. That's very important.
Right.
So in the cost optimization, this chapter, like I talk about like all of different aspect, and mostly it is about like the things and the thinking behind it, because the appliance can be different, because in every different system it can be a different case how you can do cost optimization, but the thinking behind it is like sort of the same.
Can you touch a little bit about that? The title, "The Hidden Cost of Software Development." It's, I mean, it's kind of, it's not related to the cost of the. I mean, is it, what's the hidden cost of software development?
Yes. So basically, like the hidden cost of software development is like basically like there are like a lot of things that people know that okay, this thing costs that much, this thing costs that much, but then there are like a lot of things like system, there can be some issue, there can be like you are planning that in 3 months we will develop this much feature, right? But there can be a case that you have like some sort of like people intruding into your platform.
Right.
There can be that there's like a change in npm module and then your system is not working because you're
Right.
dependent on that.
Right.
It's like there are like so many hidden factors that
Right.
we actually don't understand when we're doing the cost
Right.
calculation,
Right.
because there's no field for like what happens if this thing goes down, what happens if this underlying architecture is down. So
Yeah.
this is something that there are a lot of hidden factors, we also have to sort of keep them in mind and have that buffer.
Yeah. I had a talk with one entrepreneur who was talking to me about this specifically, and going back to the same system that we did with Kafka Stream. I mean, when I chose Kafka Stream, and it's a stateful, I wouldn't say database. There's a queue, and there's stateful workers, and then there's kind of resharding of keys, and it's a mess. And
Yeah.
the hidden cost of having this is basically kind of keeping 10% or 15% of a DevOps person to
Yeah.
stabilize the system and to understand the problem. And I didn't understand this. And this is where kind of, I mean, that entrepreneur was experimenting with trying to figure out whether an AI can help you. I mean, whether maybe the internet knows that there's a hidden cost, and maybe could be kind of an AI architect that can help you on every stuff, basically tell you what is the hidden cost here of maintenance.
Yeah.
And it's I mean, how often does an npm package upgrades? What's the? I mean, these are interesting.
Yeah, the whole the node version update, and then in that, like in your scenario, what was the hidden cost? The hidden cost was he has to actually pay to maybe like one or two software engineers which are actually managing that Kafka thing.
Exactly.
And then he was thinking that these two developers will develop these XYZ feature, but
Right.
they're focusing on that aspect as well, which he was not expecting. So yeah, that was like something that is like the hidden cost.
And you're not planning to fix this. You plan just, I mean, let's just turn the fire out. Let's clean the disk. Let's do some stuff, and then super interesting. Huzaifa, any other stuff you want to mention about the book? I mean, we covered kind of the basics, but
yeah. So I would just like add like one last thing, that if you are like looking to understand the whole system design process, because in this book, like I try to cater like all the different aspect of, as we talked in this particular show as well, that there are like different aspect of the whole system design. There might be few like 2-3 other aspect that I haven't covered, but like most of the important one I actually compiled the information and put it there. So if you want to just maybe it can be a case, like I remember like back in the days, like 1 or 2 years ago, I did a course of algo expert from the person was Clem. So that was very basic. I did the whole course in like 2 days, but I get a lot of value from that course because it helped me in these 2 days. I refreshed the whole like all the concept again. I was like, oh, that's good, like and then you might have an interview or talking to someone, you have like all the concept clear, because sometimes you have like a vivid memory or of some concept. So this book can also, like if you are like a very senior or like solution architect, you have like 10-15 years of experience, then in that case it can help you, just like you can again read it and just like just understand it.
Right. I do. I agree. It's very easy to read, very easy to consume.
Yeah.
Sometimes you have to dig further in other places, but it's got kind of like kind of a mental checklist in many cases.
Yeah.
Awesome,
Yeah.
man. Awesome.
Yeah.
Man, thank you for joining in your 3 a.m. It's time to go back to bed. It was great talking to you, and I hope to see you back on our Slack channel and involved in the Wing
Yeah.
project.
Yeah.
And we got Nathan loving the book and thanking you. And I don't know if you know, but we have a thing here between topics. We go through a song. So
Yeah.
today we're gonna listen to Hobo Johnson.
Okay.
The song is Subaru Crosstrek. And thank
Okay.
you very much. And we
Yeah.
listen.
Thank you guys for inviting me, because it is like very nice. It's like the first show, I would say, like, or the first person I'm actually talking about the book and explaining why I've written it, like why this happened. And like, I'm very thankful that you guys gave me the opportunity to talk about it, like, and yeah, it was great being on the show.
Thank you very much.
Thank
So
you.
and I'll see you next time on the next
Sure.
maybe before the movie, before you make
Yeah.
the movie about it.
Yeah. Sure.
So let's hear it to Hobo Johnson, Subaru Crosstrek. Thank you. Bye bye.
Thank you. Bye bye.